Hi everyone. In this video, we would be designing a very popular Amazon interview question, which is ATM machine. So let's get started. So this is how the ATM machine looks like. So whenever you go to any ATM machine, you would be able to perform several operations. The operations would be inserting the card into the ATM, right? So here you can see that there is a place to insert the card. Once you insert the card, you have to enter the PIN. And once you enter the PIN, and let's say it is correct, then you would be having several options on the screen. The options would be deposit some money, withdraw some money, or check the balance. You need to select that option by clicking on the buttons which you can see over here. All right. So you will be clicking one of the button and it will select a particular option. Let's say you selected a withdraw money option. So in that case, the next prompt would be to write the amount which you want to withdraw. So let's say I want to withdraw 5,000 rupees. So once I enter the 5,000 rupees, this ATM will check whether it has 5,000 rupees or not. And it will also check whether the user's account also has the 5,000 rupees or not. Once everything is done, it will give us the 5,000 rupees through this place. So I hope now you understood the entire ATM machine which we would be building. Now let's try to gather the requirements based on whatever we have understood. So just now we saw that our ATM machine has lots of operations, isn't it? And obviously in the interview, we won't be able to cover all the operations. So we need to ask the interviewer that what all core operations we need to implement in our ATM machine. All right. So let's say the interviewer asks us to implement this cash withdrawal operation. Okay. So once he asks us to implement this particular operation, the second question that should come into our mind is this particular question. So over here, we are asking that should our ATM have only one variable representing the amount in the ATM, or should the ATM have different types of notes like 2000 rupees note, 500 rupees note, or 100 rupees note, right? So let's say the interviewer asks us to have this different types of notes, and he also wants us to make this particular component extensible. By extensible, I mean that in future, we should be able to add, let's say 10 rupees note, 50 rupees note, 200 rupees note, etc. Okay. And let's say interviewer himself says that we have to design the system which would support n number of ATM machines. All right. So we have to keep these three things in mind while designing our ATM system. Okay. So now let's check out each and every entity present in our ATM system before understanding the entire flow. So here's the class diagram of the ATM system. Before checking out all the entities in the class diagram, let's first try to understand the ATM database, or you can say ATM table. All right. So let's say there's one bank and that bank has thousands of ATM machines all over the town. So obviously we need to store all the details of that ATM machine somewhere. Hence we would be creating this ATM table wherein each row represents the details of a specific ATM machine. For example, ATM machine 1 would have the ID as ATM1 and it would have this cash. All right. And further, we have segregated that cash into different types of notes. Like there would be 5 2000 rupees note, 5 500 rupees note, and 20 100 rupees note. All right. Now the thing is, let's say you go to the ATM machine 2 and withdraw the money. So basically what will happen is that ATM machine 2 will be updating this particular row. It will deduct the cash available and all the notes which are dispensed. All right. And it will also change the status. Now, what is the status? We'll try to understand in a moment. But right now, I assume that you understood two things. First is each and every ATM machine would have their details in this ATM table, and they would be updating those details whenever someone withdraws the money or whenever the state of that ATM machine updates. All right. Now coming back to the class diagram, let's see each and every entity one by one. So the first thing is the ATM repository. So as you know, repository layer is a layer which stores all the CRUD operations like saving the ATM details, getting the ATM details by the ID, updating the status of the ATM machine by the ID, and so on and so forth. So all those functions would be kept into this repository layer. And this CRUD functions would be operated on the ATM table or ATM database. And as you know, we won't be able to use real database in the LLD interview or the machine coding round, right? So instead of using real database, I have used this in-memory hash map, wherein the key would be the ID of the ATM machine and value would be the entire row. All right. So this ATM object represents the entire row. So each and every row would be having the ID of that machine, the status of that machine, the cache available, and the count of different types of nodes. And instead of using a string data type for the status variable, I have used the enum just for type safety. Okay. Now, what are these different types of status like idle, card inserted, authenticated, dispense cache, etc. And what is the reason behind using this status? So in order to understand this thing, we need to first understand the ATM machine class. So let's first try to understand that. So here we have that ATM machine class. And one thing that you can observe is there is one variable called as state. Now, why am I using this state over here? Now, in order to understand why we are using that state variable, let's come back to this diagram. So let's assume that you go to this ATM machine and directly press this withdraw button. So what do you think? Will this withdraw button work or not? Obviously not, right? Because you haven't yet inserted the card. Before even inserting the card, how can you withdraw the money, right? So that's the thing. You have to first insert the card. So let's say now you inserted the card and again you press the withdraw button. Now tell me whether it will work or not. Obviously it will not work. Why? Because you haven't entered the pin yet. So let's say now you entered the pin as well. Now again you press this withdraw button. Will it work? No. Why? Because assume that the entered pin is the invalid pin. So if it is the invalid pin, how come the ATM allow you to withdraw the money, right? So now let's assume that you have inserted the card, entered the pin, and the pin you entered is a valid pin. Now if you press this withdraw button, it will allow you to withdraw the money, isn't it? So this is how your ATM machine class would look like. It will have various functions like withdraw cash, insert card, eject card, enter pin, etc. And each of this function will need to first check the state of that ATM machine and respond accordingly. So if you haven't yet inserted your card and you try to press the withdraw button, then it will show this message, that is, please insert your card. Now let's say you inserted your card, then it will show this message, that is, please enter the pin. Okay, so each and every function over here would be behaving differently based on the state of that ATM machine, isn't it? So this is how we can write the code for this ATM machine. But the problem over here is that this ATM machine class is violating the solid principle. First is it is violating the single responsibility principle because this class alone handles all the logic for this different functions, right? Second is it is violating the open close principle because if you want to add some different state or if you want to update the message, then you need to come to this ATM machine class and update this code, isn't it? So all in all, you are violating the solid principles. So in order to overcome that, what we can do is we can use state design pattern. The state design pattern would be very helpful over here. Why? Because in the state design pattern, each and every function would be behaving differently based on the state in which the machine is. So let's say that you try to withdraw the cash and the machine is in idle state. So in that case, it would display this message. Okay. And if the machine is in card inserted state, then it would display this message. indicating the user to enter the PIN. Okay. So in the state design pattern, we won't be writing this if else statement. Instead, we would be having a separate class for each and every state. So here are the different state classes, and each of the state class implements all the functions like insert card, enter pin, select option, etc. All right. And the cool part over here is the insert card function in the idle state would have the different logic compared to the insert card function in the card inserted state, and so on and so forth. So basically each of the state classes will have their own implementation of those functions. And you might have noticed that I've highlighted some functions. For example, in the idle state, I've highlighted insert card function and get status. Why? Because in this particular state, those two functions are the important functions, because the other functions will either have no logic or it can throw some exception. Similarly, in the card inserted state, the user can just enter the PIN and eject the card. In the authenticated state, the user can select the option like whether user wants to withdraw the money or deposit the money or check the balance. So he will select one of the option. Now currently we just have one option, that is withdraw option. And finally, when the user selects the withdraw option, the state of the ATM machine will go into this dispense cash state, wherein user will be entering the amount which he wants to withdraw. So dispense cash is one of the operation which he can perform, and he can also perform the eject card. So I hope now you understood why we are using the state design pattern and how this design pattern is used in our ATM system. Now coming to the ATM machine class, this ATM machine would have a state. Okay, so it will be either in idle state, card inserted state, authenticated state, or dispense cash state. So on the basis of the state variable, these operations would behave differently. All right, we'll directly see this in code. Now apart from that, this ATM machine has this ATM repository object as well. The reason behind this is ATM machine would be interacting with the database, isn't it? So it needs to update a specific row. So for doing that, it needs the ATM repository object. And ATM machine has this ATM object because this represents the row on which this ATM machine would be working. Okay, so it will update this particular ATM object and it will put that into the database after updating that. Apart from that, it also has this current card. So whenever any user inserts the card, that card will be stored into this variable. So ATM machine has a relationship with the card. Card will have the card number, the PIN, and the account with which that card is associated. So account will just have the account number and the balance which the user has. All right. So I hope now you understood the ATM machine class as well. Now coming to this dispense cash state. So over here, whenever the user tries to dispense the cash, behind the scene, we would be using this chain of responsibility design pattern. Now, why are we using chain of responsibility design pattern? We'll talk that in a moment. But before that, let's try to understand these classes. So you might be knowing that in the chain of responsibility design pattern, we should have this set next function. Okay. Why? Because we need to build the chain, isn't it? So with the help of this function, we would be building the chain wherein the first node would be this 2000 dispenser. The second node would be 500 dispenser and the third node would be 100 dispenser, and so on and so forth. And in future, if I want to add some other types of node, like let's say 10 rupees node, then I can just create one class over here and make it implement this interface. Okay. Now the second function is can dispense function. Now reason behind using this function is, let's say user wants to withdraw 510 rupees. Okay. And the ATM has 6000 rupees, which is obviously greater than 510, right? So this function will first check whether ATM has money which is greater than the requested money. It will also check whether the user has more money than the requested money in their account. And the third thing it will check is whether this request can be fulfilled by the nodes which are present in the ATM machine. So for example, this particular request cannot be fulfilled in this case. Why? Because although the ATM has more money than the requested money, but ATM does not have 10 rupees note, isn't it? It just has 500 rupees note or 100 rupees note. So it can at max give 500 rupees, right? It cannot give 510. So the entire request would be rejected. So we have to first check whether the request can be fulfilled or not. If we can fulfill that request, then only we will dispense that, because we would be updating that table, isn't it? So this was about the chain of responsibility design pattern. And now coming to why do we use this design pattern over here? So the reason is quite simple. So assume that we don't use this design pattern. So in that case, what we would do is we would write that logic in this dispense cache function itself. That is, we would loop through all the types of nodes, right? For example, we would first go to 2000, then 500, then 100, and dispense it. Okay. But let's say I want to add some other nodes, for example, 10, 50, etc. Then I need to come into this class and update this particular function, isn't it? Which is clearly the violation of the solid principle. So that's the reason why I decided to use chain of responsibility design pattern over here. Okay. So I hope now you understood the entire class diagram of this ATM system. So now let's check out the output. This is the main class. Over here, I first created the card object. The card would have the card number, the PIN, and the account. And in this account, we have 5,000 rupees. Then I've created two rows in the ATM table. The first row will have this ID, and it will have 5 2000 rupees note, 5 500 rupees note, and 20 100 rupees note. Similarly, ATM 2 would have this many notes. Okay. Then I've created an instance of ATM machine 2, and this machine 2 will have this ID. It will be basically interacting with this particular row. Okay. And then what I'm doing is I'm going to that ATM machine 2 and performing some operation like inserting the card, entering the PIN, selecting the option, and then dispensing the cash. So over here, I'm trying to dispense 1000 rupees. Point to note over here is the balance in my bank account is 5,000 rupees, and the amount of money present in ATM 2 is 500 rupees note, that is 1000, and 100 rupees note, which is 500. So total 1500 rupees are present in ATM 2. So it should basically dispense 1000 rupees, right? So let's run the code. So first the card was inserted, then the user entered the PIN, and that PIN was validated by the ATM. And then we selected the withdrawal option. And finally the ATM dispensed to 500 rupees note. Why? Because we selected 1000 rupees. Okay. So now let's try to change this amount. So instead of 1000, let's try to select 1300. Now let's rerun the code. So now it is giving two 500 rupees note and 300 rupees notes, which is good. Now what we'll do is we'll try to update this 1300 to, let's say, 1500, or let's say 1600. Now let's rerun the code. Now it is saying that ATM has insufficient cash. It cannot dispense 1600. Why? Because ATM just had 1500, isn't it? So again, this is also correct message. Now instead of 1600, let's select 1400 and 10. Now if I run the code, the message which we will get is it cannot dispense requested amount with available denomination. obviously the ATM machine has 1500, but it cannot give 1410 because it does not have 10 rupees note. So again, this message was a valid message. So I hope now you understood the output. So now let's check out the code. So these are the different packages which I have created, like chain of responsibility, enums, factory, model, repository, service, and state. So let's see all of these classes one by one. Let's start with the chain of responsibility. So over here, I've created this cash dispenser interface, which will have these three functions, which we already saw in the class diagram. Now there would be three types of dispenser: 2000, 500, and 100. So coming to the 2000 dispenser, this dispenser would be implementing all this function. The first function is very easy. We are just treating this function as the setter. So I'm just going to update this particular variable. So this variable is basically used to go from one node to another node in the chain. Okay. So we need to build the linked list, right? So that will be done with the help of this variable. And we have this can dispense function. So over here, what we are doing is we are first getting the count of nodes in this ATM. Okay. So we'll get the count of 2000 rupees node in this particular row or in this particular ATM object. And then I'm using some math to get the total number of 2000 rupees nodes which we can deduct. And then I'm finally deducting that from the requested amount. So if the requested amount becomes 0, we'll stop going forward in the chain, else we'll keep on going to the next node. Okay. So I'm asking the next node whether that node can dispense this much amount or not. All right. If it can, then we'll stop, else that node will again send the request to the node after that. Right. So this logic is same for all of these handlers. Only thing is here we will be getting the 500 count and here we would be getting the 100 count. Rest all these things remain same. And in the dispense function as well, we would be using the same logic. Only change is that we would be updating this ATM row or ATM object, right? Because we are actually dispensing that note. So I hope now you understood all this dispensers. And we are also building the chain with the help of this cache dispenser chain builder. Here I'm creating various nodes like D1, D2, D3. D1 is nothing but 2000 dispenser, D2 is 500 and D3 is 100. And I am connecting them. That is D1 will be the head, D2 will be the second node and D3 will be the third node. Okay. So whenever someone calls this function, we would be giving them the head of the chain. Now coming to this ATM status enum, here we would be having this 4 status and we already understood that why we are using this status. The reason is we are using the state design pattern in our system and I want to know the state of the ATM machine from the database, and in the database we would be storing this status, right? So that's the reason why we are using that ATM status. Now coming to the model. So first is account. Each and every account would be having the account number and the balance. And card would be having the card number, the PIN and the account with which it is associated. And the ATM would have these attributes, which we already saw in the class diagram. Okay. Now, apart from that, we also have this repository. And this repository will have this CRUD operations, which will be performed on that in-memory database. All right. Then the main class is the service class. So over here, this ATM machine would be using this ATM repository in order to fetch this particular object. So in the constructor, I am fetching that ATM object based on the ID. Okay. And I'm saving that into this variable so that if any update is there, I'll directly update this object and save this object into the database again. And then each and every machine would be having the state, isn't it? because we are using the state design pattern. And this machine would also have the card. So if someone inserts the card, this would be having some value, else it would be null. And this ATM machine will have this operation. And the good thing over here is we are not using the if else statement in these functions. Instead, we are telling the specific state to run this function. There is this ATM state interface which has all these functions. All right. And this particular ATM state will be implemented by 4 different states. So let's see all of them one by one. So the first one is the idle state. So over here, one main function is this insert card. Here we would be inserting the card. That is, we would be using this setter to update this variable. And once we update that variable, we would be going into the next state. That next state is called card inserted state. Okay, so let's go to the next state. So now if someone calls this function, it will not do anything. Instead, it will just print that card is already inserted. So here you can clearly see that in this particular function, the logic was different and the logic over here is different. Why? Because earlier we were in idle state and now we are in card inserted state. So that's the reason why the behavior of the same function varies based on the state. Then in the card inserted state, we would be entering the pin, right? So this is that thing. So here I am checking whether the pin is valid or not. If it is valid, I'm printing this message and I am moving this ATM machine into the authenticated state. All right. And by the way, these states would be operated on a specific machine. So that's the reason why we have this ATM machine attribute in all of the state. Okay. Then once we go into the authenticated state, the operation which we can perform is this select option. So over here, we would be having different options, but right now we just have only withdrawal option, right? So over here, when the user selects the withdrawal option, we would be going into the next state, which is the dispense cash state. And in this dispense cash state, this is the function which we can call. In this function, we would be checking total 3 things. The first one is whether the ATM balance is greater than the amount or not. If it is less than the amount, in that case, I will be printing this message and eject the card. Now, what is this eject card? So eject card means I'm just removing the card from that machine automatically. All right. And since the card is removed from that machine, the machine will directly go into the idle state. So I'm updating the state of that machine. And instead of creating the object manually like this, we can also use factory design pattern. Why? Because let's say in future, the idle state also takes one more parameter, let's say XYZ. Then I need to go at each and every location and update that second parameter wherever we are creating this object, right? So instead of doing that, we can just centralize the object creation process via the factory design pattern. Okay, so I hope now you understood why we should be using factory design pattern. So coming back to this dispense cash function, if the ATM balance is less than the amount, in that case we would be ejecting the card. Okay, and we also have second check, which is whether the balance of the account is less than the amount or greater than the amount. If it is less than amount, then also we'll be printing this message and eject the card. And the third check is whether we can dispense the notes from the ATM or not. If we cannot dispense the note, then we will be printing this message and eject the card. All right. And if we can dispense the notes, we would actually dispense them and update them over here. All right. Here I am updating the total available count. Earlier, I just updated the count of the 500 rupees notes or 2000 rupees note or 100 rupees note. But over here, I am updating the total cash available in the ATM machine. All right. And after that, I'm also updating the user's account balance, right? So these are the two things we are updating, and we are moving this ATM machine into the idle state. Okay. So instead of doing that, we can just eject the card here itself. So card would be ejected and the ATM will be moved into the idle state. So these were all the classes present in this ATM system. So I hope now you understood this system. If you did, then please like the video and subscribe to the channel. Thanks for watching.